4 different mines. We have all these numbers. We have obtained these numbers. And by the use of these numbers, we are going to find A, B1, B2, and B3, and which will take us to the final formula, which is this one. This equation will give us the thickness of the crown pillar between surface mining, an open pit, and underground mining, if we are going to use block cave. Now, just a little bit of conclusion. For sensitivity analysis of the selected variables, and hypothetical example is studied in this table. A hypothetical example where we have a span of 200 meters, quite a typical span, quite a typical width for a block, caving block. As we know, the very minimum, the bare minimum of the each side of the square or rectangle in the block has to be 100 meters. That's the bare minimum. So it's 200 with a height of 300 meters, again, typical, and all the others. Using our established formula, the obtained formula, and these numbers will get to the thickness of 221 meters. Now, assigning different values to each variable, the results of sensitivity analysis are shown in this figure. S, that is the span, the width of the base of the block, has the most important effect. As you can see, the blue line, as it increases, as this width increases, the necessity of the pillar and the widthness of the pillar increases sharply, even more sharply than the height, which is H and the red curve. This is what we didn't know. RMR, of course, important again. It has quite the gray line, the green line, between gray and green, whatever it is. Has the adverse effect, of course. The higher the RMR, the thinner the thickness of the crown pillar that we have to leave. But of course, we all know that if the RMR is very high, we cannot use block caving method. On the other hand, we would like to have lower RMR. What is found in here, which is very important, is that C, cohesion strength, has a relatively unimportant effect on the thickness, and even worse than that, the specific weight has a very unimportant, almost negligible effect on the thickness of the pillar. Therefore, the next people doing research like this, I think they may as well just ignore the specific weight. Therefore, what we can conclude is that established formula can be practicable in all situations where a combined open pit and block caving method is used. Similar methodology can be used to determine appropriate formulae when other underground methods are used, and sensitivity analysis shows that the crown pillar thickness is most sensitive to the block dimensions, in particular to the width of the block, and least sensitive to the specific weight. Thank you very much.
Any questions for the professor?
over here.
Once you know the...
Use that.
Once you know the dimension that you need for a pillar between the block cave and the surface, you've got to do something to that material, otherwise the block cave doesn't know it's going to stop, say 220 meters from going through. How do you actually stop that pillar? How do you stop the cave without doing something to the rock strata in the form of supporting it or something like that?
No, we don't do anything to the pillar because we don't have access to the pillar. The pillar is on top of the block, and we only have access to the bottom of the block. And on the other hand, we would like the pillar to be caved sometime anyway. As you know, in block caving methods, we do not only depend on the weight of the ore in the block. That if we assume that the block caving method is bound to fail, we have to depend on the weight of the millions of tons of material which are in the block, above the block, and around the block. Therefore, even the weight of the pillar has to help us, not only to start the cave, but also to break the ore as it goes down to the drop points. No, we do not do anything with it, but if you imagine that the thickness of the pillar is going to be in terms of few hundred meters, and the height of the block is also going to be in the range of a few hundred meters, there is not, the pillar instability is not going to hinder us in the beginning when we need it to be stable. But in the end, it's going to help us when we need it to be unstable.
Any other questions?
Hi. You said that the equation that you formulated is applicable to any case where you have open pit and underground mine. That means that it has no limitations and that your 4 case studies cover all possible scenarios?
Definitely, that is not what I said. Slightly different, but that slightly is very important. It works wherever there is an open pit and block caving method. But if one wants to obtain another formula for other mining method, underground mining methods, it will be they can use similar methodology to find that.